In 2017, I built an interactive button for the xScheduler, and it was a success with the viewers of my Christmas show. For more information, please see the link in the description below. This year I needed to modernize this prop by adding some new features. The results exceeded my expectation. Let's take a look. The physical structure of this prop did not change. The same size project box, pole, and fixtures were used in this build. However, I've added metal waterproof push buttons with circular green continuous lights. I also added an EL panel sandwiched between acrylic sheets. The instructions on the panel were added to the top acrylic sheet using vinyl letter transfers. The details on the top of the box was accomplished using a combination of vinyl letters and spray paint. The following items are needed for this build: ESP32 module, 40mm waterproof metal push buttons, 20 by 10 centimeters EL backlight panel, waterproof project box, 12-volt power supply, custom vinyl lettering, 1/8" clear acrylic sheet, and a DC to DC buck converter. The circuits for the switches are the same as before, using GPIO 12 and 14 with 10K ohm resistors pulling to ground. The common of both switches are connected to 3 volts. The notable differences are the wires connected from touch pin TO and T3 of the ESP32 to the metal surface of the switch. This is how the touch function is added to the outer rings of the switches. More on this later. The ESP32 has 10 touch channels. In this example, TO and T3 are used. Capacitors continuously charge and discharge on each touch channel. This produces a pulse, which is counted over a given time. The touch sensors monitors capacitance changes by observing the pulse count. If the pulse count for a channel drops below a specific threshold, a hardware interrupt is generated. This threshold may be adjusted for parasitic capacitance or other types of interference which can affect the pulse count. The metal surface of the push-button switch is isolated from the outer edge. The switch is wired for push when the center is pressed and for capacitance when the outer ring is touched. A wire is tightly wound around the metal base of the switch by twisting the ends. A wire lead is then soldered to the twisted end and connected to one of the touch pins of the ESP32. Touch interrupt listeners with event handlers and a threshold are configured and attached to TO and T3 inputs in the setup section of the sketch. A touch flag for the associated interrupt is set to true when a switch is touched and the interrupt is executed. This touch flag is queried in the loop by the getTouchState function. If the touch flag is true, it is first set to false and the time of the successful touch event is stored for the next comparison in the since_last_touch_TO or since_last_touch_T3 variable. The touch delay comp function then queries whether enough time has passed since the last touch. If the function returns false, the if query is finished and nothing happens. If the function returns true, the sendData function is executed, sending the data to the xScheduler. The Wi-Fi Manager library is also included and implemented in this sketch to negate the need to hard-code the Wi-Fi credentials. An electroluminescent display is a flat panel created by sandwiching a layer of fluorescent material between 2 layers of conductors. When a current flows, the layer of materials emit visible light. EL devices are primarily composed of electrodes, an emissive layer, and a single or multi-layer of insulated dielectric that requires high-frequency alternating current to excite the molecules and emit light. Power is supplied by an inverter that converts the DC from a power source into AC. The brightness of the light depends on the amplitude and frequency of the voltage waveform applied across the panel. The brightness of the EL devices increases as the voltage or frequency of the driving signal increases. The EL panel used in this example has multiple electrodes, providing many points for connecting the electrical leads from the inverter.
You know Dasher and Dancer and Prancer and Vixen. You know Dasher and Dancer and Prancer and Vixen.
Links to the sketch and other items in this video are in the description below. Please like and subscribe. Thanks for watching.